Hi, future doctors. Welcome to the next class. So, in previous class, we discussed energy stored in a capacitor. So, what is the formula we gave? Q is equal to half CV square, Q square by 2C. Another one is QV by 2. Now, energy density we will see now. What is energy density? So, amount of energy stored per unit volume of the capacitor. So, if this is a parallel plate capacitor, of each plate area capital A, separation is going to be small d. What is the volume of this? Area into distance. So half CV square divided by area into distance. This is the amount of energy stored per unit volume. So generally what is the capacitance in terms of area means epsilon naught A by D. Now, what is the voltage and electric field between these two relations? Always VDE relation we came to know E equal to V by D. This one we will have been using E equal to V by D. Then V is ED. See the difference? Volume I am writing like this. This V normal I am writing. In place of this V, E D whole square divided by area into distance. Now this area and this area is going to be cancelled, correct? Now what is remaining? Of epsilon naught E square D square by D into D square. If these two cancel means now energy density you can see of epsilon naught E square. This is the energy density formula. So already in dimension formulas, they will ask what is the dimension formula for epsilon naught E square or half epsilon naught E square. At that time, it is difficult to remember. But energy by volume, we can write very easily. Energy dimension formula, work done, ml square T power minus 2. Volume means L cube. So m L power minus 1 T power minus 2 is the dimension formula for half epsilon naught E square or energy density. This is equal to pressure. Pressure dimension formula is also going to be same. So this is the another formula, another important formula. Now energy stored in a capacitor formulas now half CV square, Q square by 2C, QV by 2. Now new one, U by V is equal to half epsilon naught E square. This volume is coming this side means one of the year in NEET final exam they ask this equation of epsilon naught E square into volume. What is this volume? Of epsilon naught E square area into distance. So many students will think half epsilon naught E square only answer. Half epsilon naught E square is energy density of epsilon naught E square into area into distance give energy stored. This is in terms of electric field between the two plates and permittivity of the free space. If medium is going to be there in place of epsilon naught, we will write K epsilon naught. So that is common for us. This is about this one. Next, on this, so they may ask problem on this equation. The time you have to solve very clearly of epsilon naught E square. So this is electric field between the two plates. So whenever two plates separated, metal plates separated with positive and negative charge, so separation is there, voltage is supplied means definitely you are going to get electric field. What is the equation there? Electric field equation in between sigma by epsilon naught. You should not forget this equation. What is sigma there? U by A, U by epsilon naught. Next, how much force acting on this one of the metal plate they will ask. Force on the metal plate. So Q minus Q. So what is the force on the metal plate means either A or B, any one plate you can take. Now B is in the electric field. How much electric field produced by A means E is equal to sigma by What is the electric field produced by A means? Sigma by 2 epsilon naught, correct? Then what is sigma? Q by 2 epsilon naught A. This is the electric field. Now minus Q is going to be present in that electric field. Then what is the force formula? F equal to minus Q into, they will ask magnitude of force. Therefore, QE. Now Q into what is E? Q by 2 epsilon naught A. Therefore, force acting on one of the plate, very important formula. Q square by 2 epsilon naught A. This is the force acting on one of the plate of the capacitor due to another metal plate. Q square by 2 epsilon naught A. Next, we will discuss combination of capacitors. So, combination of capacitors means two combinations will be there. One is series combination, another one is parallel combination. Now, what is series combination? If you are taking either 3 or 2 capacitors, this is called end-to-end connection, they will be saying. So, if 3 capacitors like this, if we are taking, this is called end-to-end connection. C1, C2, C3. C1, C2, C3. Now we have connected, this is second end is connected with first end. First and second end, like this. Second end is connected to first end to end connection. So these ends are free. In this combination, we will call series. Now, what is the effective capacitance? If it is connected to a battery of voltage V, what is the effective capacitance means? CS they will write. Okay. Now, what is the CS formula we will write? How we will write means all these three capacitors connected in series, the charge is going to be traveled. So the amount of charge passing through C1, C2, C3 should be same. So from A to B, how much charge is traveling? Here also from A to B, same charge is traveling. According to Yours law, what is Yours law? We said Q is equal to CV. If you apply for this one, Q is equal to CSV. If you apply for this, so charge on each and every capacitor is going to be same. Q1, Q2, Q3 is going to be same. Q1 is equal to Q2 equal to Q3 equal to Q. Therefore, in place of Q1, what we will write? C1V1. The amount of work done to bring charge from here to here is going to be V1. Q2 is equal to C2V2. Q3 is equal to C3V3. So this is V1. This is V2. This is V3. Therefore, V is equal to V1 plus V2 plus V3. From this, what is V1? Q1 by C1. Q2 by C2. Q3 by C3. What is V from this? Q by CS. All Q1, Q2, Q3s are same. Therefore, Q by CS equal to Q by C1 plus Q by C2 plus Q by C3. If all Q's cancel, then what you will get? That is the final equation. 1 by CS equal to 1 by C1 plus 1 by C2 plus 1 by C3. So, how they will ask questions on this means, if capacitors are in series, what is the ratio of charge? Q1 is to Q2 is to Q3. Charge is same, 1 is to 1 is to 1. What is the ratio of potential? V1 is to V2 is to V3. You can see V1 is going to be Q1 by C1. V2 is going to be Q2 by C2. V3 is going to be Q3 by C3. Therefore, what you will get here? Q's are same. 1 by C1 is to 1 by C2 is to 1 by C3. Correct? This is the effective capacitance formula. So 1 by CS equal to 1 by C1 plus 1 by C2 plus 1 by C3. If two capacitors connected, 1 by CS equal to 1 by C1 plus 1 by C2. So if we are taking LCM C1, C2, C2 plus C1, now CS is C1, C2 by C1 plus C2. If n different capacitors connected, 1 by C1 plus 1 by C2 plus and so on, 1 by Cn. If n identical capacitors connected, if n identical capacitors. If n identical means same capacitors connected. 1 by Cs is 1 by C plus 1 by C plus and so on 1 by C. How many 1 by Cs are there? N into 1 by C. Then what is Cs? C by N. Like this you have to get. Isn't it? Now another important point on this, if two capacitors connected, 2 microfarad, 3 microfarad, what is the effective capacitance means? Cs is 2 into 3 by 2 plus 3, 5. So 6 by 5. This 6 by 5 is going to be 1.2. This 1.2 is less than least capacitance among the given two capacitors. That is going to be 2. 1.2 is less than 2. Therefore, they will write one important point. What is that one means? Cs, resultant capacitance, is always less than minimum capacitance among the capacitors. If you are taking 3, 1, 2, 3, your effective capacitance will be less than 1. If you are taking another 3, 10, 20, 100 farads or microfarads, then your effective capacitance is less than 10. That is the meaning of this effective capacitance if capacitors connected in series less than the minimum capacitance among the capacitors. Next, what is the voltage across C1, C2? They will ask like that. At the time, here charges are going to be same. Charge is CSV. Q is equal to CSV. Like that, Q1 is equal to C1V1. Okay. Now, what is CS if you got? For two capacitors, CS value is C1, C2 by C1 plus C2 into V is equal to C1, V1. If we equate these two, C1, C1 will be cancelled. Now, what is V1? C2 by C1 plus C2 into V. Like that, what is V2? C1, V by C1 plus C2. Like that, if three capacitors connected, so this CS we have to replace. How we have to replace? Like this, you will get. So 1 by CS is 1 by C1 plus 1 by C2 plus 1 by C3. So what is LCM? C1, C2, C3. So C2, C3 plus C1, C2 plus C2, C3, C1, C3, this one. C1, C3 and C1, C2. Then what is CS means? C1, C2, C3 by C1, C2 plus C2, C3 plus C3, C1. This is the effective capacitance. Now, from this equation, you can substitute here. What is CS? Then definitely you will get. So, what is CS means now? This one. C1, C2, C3 by C1, C2 plus C2, C3 plus C3, C1 into V is equal to C1, V1. Now, what is cancelled? C1, C1 will be cancelled. Now, V1 is equal to, see the formula, C2, C3 by C1, C2 plus C2, C3 plus C3, C1 into V. Whenever 1 is coming, here C1 won't come. Now what is C2? Sorry, V2 with our common sense, voltage across second capacitor. Voltage across second capacitor formula. So with our common sense, we can write C1, C3 by C1, C2 plus C2, C3 plus C3, C1 into V. Now what is V3? So C3 will not come. C1, C2 divided by C1, C2 plus C2, C3 plus C3, C1 into V. So this is the another equation. So V1 is coming, C1 won't come. V2, C2 won't come. V3, C3 won't come. So like this also you can remember. This is when two capacitors connected. This is when three capacitors connected. Understood? So you can practice this parallel combination we will see in next class.